Let's do a few more examples using the area of circles. Finding the area of the shaded region, we need to make a plan and we need to show our work. So let's first, oops, kind of freaking out on me here again a bit. The shaded region, if it's hard to see on your screen, is this region in between these two circles. So our plan then is, without even looking at any numbers or anything like that, in order to find the shaded region, we need to find the area of the big circle. So we need to find the area of the big circle. And we need to subtract from the area of the big circle the area. Let's see if I can do this. The area of the small circle. So I can subtract that area of the big circle. Oh, rather, if I can subtract the area of the small circle from the area of the big circle, then we'll get that shaded area. Okay, so let's think about this. The area of the big circle is, well, the area of a circle is pi r squared. Maybe we can write that as an aside somewhere. You know, area of a circle is pi r squared. So the area of my big circle is going to be pi times my radius of my big circle. Let's go ahead and draw that in. The radius of the big circle, which we'll call big R, squared. And the area of the small circle is pi. And then we have this little r right here, so that's little r squared. Fortunately, it gives me little r, so this is pi. Little r is 2 squared, so that's 4 pi. So then all I need is big R. Well, let's try to find big R. Big R is the radius of this big circle, and at the beginning of the problem, we're given the width or the diameter of that big circle. So remember that the diameter is equal to twice the radius. So if my diameter is 10, well, it would make sense for my radius to be 5, right? 10 divided by 2 is 5. So pi times 5 squared minus pi times 2 squared, that's 25 pi minus 4 pi. So then the shaded area is 25 pi minus 4 pi, or 21 pi. My units are centimeters, so that's centimeters squared. And that is the shaded area of these circles. So find the area of the big, find the area of the small, and subtract. Use the diameter to find the radius. That's really helpful for us. Let's move on. Go down here and do one more example. So we're trying to find the area of this shaded region. Take a second and think through what plan you might use. Well, a plan that I'm thinking of is, and maybe even pause the video if you want to try to work it out for yourself. Plan that I'm thinking of is that this shaded area right here, so again, we'll kind of make sure that we all know what we're talking about. This shaded area in here, that looks like it would equal the area of the rectangle minus both of these semicircles that we have right here, right? So minus 2 times the area of a semicircle. Okay, because if I can find the total area of the rectangle and subtract these two darker spots, then I get my shaded area. Okay, area of a rectangle. Hopefully you remember the area of a rectangle is base times height. which in this case, the base is 13. The height is 6. So 13 times 6 is 78. And that's the area of the rectangle. Okay, so we've already got that. That's great. That's half of our problem, basically. Okay, now we need twice the area of these semicircles. Now, hopefully, I hope that you're noticing or you're thinking about, if I'm taking twice the area of a semicircle, that's the same as the area of a circle, right? If I take 2 halves, that makes a whole. So this is just then minus pi r squared. So we're looking for the radius. I'm not given the radius. I'm given this length, which is the diameter of the circle. So remember, the diameter is twice the radius. So 6 is twice the radius because 6 is my diameter. That means my radius is 3. Okay, so minus pi times 3 squared. Minus, so pi times 3 squared is 9 pi. So maybe we leave it like this, 78 minus 9 pi. Or maybe we look to get an approximate answer. And let's bring up I'll bring up my calculator real quick. So 9 times pi is about 28.3. That's about 28.3. So we do 78. If I can get that color, 78 minus 28.3. So the area of the shaded region, that shaded area, 78 minus 28.3, or that is 49.7. We don't have any units, so we don't have to worry about the units. So you could either say that it's this 78 minus 9 pi, or if we're looking to be more precise, maybe we say 49.7.